I think now we have the right knowledge and tool to draw the graph of the log function. First, we draw the graph of the exponential function. Since log is the inverse of the exponential function, we can flip the graph of the exponential function around the axis y equals to x, and then we'll obtain the log function. First, let's draw the exponential function for the case a is larger than 0 and smaller than 1. Y starts off being very large when x is small, and keep becoming smaller across the y-axis, and becoming smaller and smaller, approaching 0. This point is 1. When x is 0, y is 1. We can see that by plugging x is 0 into fx equal to ax, and then we'll get 1 here. Another point on this graph will be when we plug in 1 into a to the x, and fx we have a, since a to the first power is a. So we can check that this point, let's just say this is x equal to 1, x equal to 1, and y is equal to a. Y is equal to a. So we'll label this point as 1a. Another point similar on the other axis, on the other side of the x-axis, is when we plug in -1. When plugging -1 into x, we have fx equal to a to the -1, negative first power. We have a over 1. Here, let's say this is -1. We obtain -1 a over 1. Oh, 1 over a, sorry. We can verify that because a is smaller than 1. We can see that this point indeed is lower than the point y is equal to 1. Similarly, when a is smaller than 1, 1 over a is definitely larger than 1. So we can see that this is higher than 1. Okay. Let's go back into drawing the log function. When drawing the log function, we flip the blue line around y is equal to x, the dashed line. When we're flipping it, we obtain this. Okay. And this x is 1, y is 0 point will flip into y is 0, x is 1. And this point will be flipped here. This will be a1. And this point will be flipped here. A over 1, -1. And this is the graph of the log function. And we draw it here, just to show it clearly about what's the case. Oops. This is a1, 1, and a over 1, -1.